So last time we moved this to the other side, we had 61 divided by 50, e raised 5r, 1.22, e raised 5r. To solve for r, we did not raise it to the power of 1/5r on both sides. Reason being, if you rewrite it this way, sure, I can get rid of squiggly over here. Yes, agreed. But does it help in finding r? Absolutely not. So how do we find r, or how did we find r? Hint, we use that. What did we use? It's right in front of you. Listen. We graphed it. So we use our calculator, we graphed it, and I traced the value to see what value of x would end up giving 1.22, correct? That number that I got was not exact. It was an approximation. If Kevin's setting is different from Chrissy's setting, then they might have answers that are slightly off from each other. We want an accurate answer. Good. We need to have a way to get that accurate answer. Okay. The problem from last time, we had e raised 5r. We had to find the rate. We used this expression because interest applied, rate is applied, or interest rate gets applied every single moment of your life. So we went with this equation, which is for continuous growth rate, decay rate, whatever. We got to this part. I showed you earlier what you shouldn't do, but last time we used the calculator, like Chrissy said, we graphed, we traced, we got an answer that was an approximate answer. Yes? Over here, things to realize. Should you use the formula A equals P times 1 plus R divided by M raised M times B? Yes or no? I gave you this, but I'm just asking, is that a reasonable equation to use? No, why not? Because it's very good. You take that fish, it's not simply growing once every 6 months, once every 3 months, does it? It's a bad fish if it did that, right? It grows continuously. So continuously would mean the growth rate is getting applied every minute, every second of its life. So this would reduce to P times E raised RT. Good. We know what P is, the initial length that you start with, 12. Okay. E. In this problem, the rate is given to us. Well, it grows about 0.21 centimeters per year. So 0.21 centimeters multiplied by time. Good. That is the function that is going to give me the growth rate of the salmon that I have at hand. Erase the top part. The problem wants to know, well, what is the value or what is the length when you observe the salmon for 3 years. So plug in T equals 3. 12 times E raised 0.21 times 3. And what is that approximate answer that you get? Many of you got this part right, yes.
22.53.
Josh, correct?
James.
22.53 centimeters. Yes. Oh, pretty steady. Okay. Not a bad size fish. Now, this is under the assumption that the salmon doesn't get caught and doesn't die. Right? Naturally. Okay. The next question is how many years would it take for it to reach 32 centimeters? Again, I made this problem up. I don't even know how long a salmon's going to get, hypothetical. I'm not going to use a calculator yet. We can't use logarithm yet. Even before you start the problem, can you guess the answer? I'll give you choices. 4 choices for this question. Ready? They're all in years. Pick everything that would apply. Don't use your calculator. Just think about the problem and tell me which one would apply. If none of them would apply, that's fine too. 32 centimeters, which sounds like a reasonable answer. You can't use your calculator. Think. Evan, do we know the answer? If none of them applies, you can tell me none of them apply. But if you have to pick, which ones would you pick, James?
I don't think any apply, but then C is the closest.
Okay, I'm not looking for an exact answer. I'm asking you to make a guess.
Then none.
Not the exact answer, using intuition.
Oh,
Yeah,
okay.
intuitively, which would make somewhat some sense.
C.
Very good. You were going in the right direction, made a U-turn, and then catastrophe. The closest that I could guess would be 3.89. It is just a guess. I'm not saying that is the correct answer. That's a guess. Why does my intuition direct me to this answer? Well, let's ask James. Why did you think?
It was in the middle between all the other answers.
Breaking my heart.
Because 7 would be 565, but A, B, or A and D are both below.
I'm gonna get your name right. Brady. Very good. I know what an exponential function looks like when I graph. Yes, it's going to go like this. We're now going to go to the negative side. Time can't be negative. So when you first initially caught the salmon, it was at 12 centimeters. Yes. At this point onward, it's going like that. Agreed. Assuming that the fish didn't get killed, assuming the rate is 0.21, 3 years go by, and it is about 22.53 centimeters. Good. That's what you found in the first part. Now the problem wants to know, well, how many years would it take for it to reach 32 centimeters? First option, 1.5 years approximately, which would be here, correct? Go up. 32? No. 2.59 is right here. No. Correct. So whatever length you observe below 3 years or up before 3 years is going to be less than 22.53. Do you agree? I am looking for 32 centimeters, so the answer has to be bigger than 3. Correct? The most reasonable one I can think of would be 3.89 because 32 seems to be close to 22. Well, it's not seems, it is close to 22.53. Agreed? Hence, the intuitive, logically reasoned answer would be 3.89. Good. I'm not saying that that is the correct answer. It's just a guess. So on a test, not just here, chemistry, biology, whatever, if you have a multiple choice question, you understand the problem properly, you can use the process of elimination and get rid of a bunch of answers and then guess best one. But if you insist on using a calculator, you can go ahead and grab it. I'm being quite gentle with the calculator because it's very sensitive and it freezes. Okay, so I put in the function 12 e raised 0.21 instead of time t. I have x instead of r. Last time we had x. So I'm going to go ahead and graph it. That's the picture I'm getting. Doesn't make any sense. Easiest way would be to do zoom 0. It automatically adjusts for the range. If that doesn't work, you go and use the window and pick the appropriate x and y limits, and you will see the picture from last time. When x is 0, I have 12 for y. Yes, isn't that what I had in the picture that I drew? Yes. I slowly move along. When I have 3, the length is 22.53. That is the answer you gave me when we did. Agreed. Now we move on to a length of 32. Yes. So I have 27.796, 34.292. A length of 27.796 occurs when the time is 4 years. Move on to 34.82 or 292 in 5 years. Agreed. So I am looking for 32 centimeters. So it has to be between those two values, what it is. So the corresponding time that you have has to be between 4 years and 5 years. Agreed. Okay. One way of doing it. Another way, what if every single answer that you pick is between 4 and 5? That's a problem. So I can do trace to keep on going. Okay, so right there, 32.068. And what is the corresponding X value? Are we able to see? James? 4.68. So in 4.68 years, the salmon would reach a length of 32 centimeters. Is that 4.68 the exact answer? No. Jane, what did you get?
Approximately 4.67.
4.67. But this problem, we got it to be really close, but in real life, it is not always this close. So what is the accurate way? I know what Beta did. Fisher, what did you use? Natural log. Okay. I start with this one, connect the dots, go to that one. So the equation that I have in the second part, the final length is 32 centimeters, yes. Initial started at 12. The rate is given to you, e raised 0.21 t. Agreed. Divide by 12 on both sides. 32 divided by 12 equals e raised 0.21 t. 2.6 approximately. One more decimal.
2.6.
666. Oh, I could have. I didn't simplify. 2.67 is what you get. 666. This equation looks quite similar to that. Agreed. Right inside is a number E 5.21. Instead of R, I have T. Good. These equations are called exponential equations because they have an exponential in them. Good. Okay. I showed you the approximate trial and error approach. What is the exact way to find the answer? Ln. You see how I put parentheses on both sides? Yes. What is Ln? Ln stands for natural logarithm. So you may ask me, well, why Ln? Ln is the inverse of exponential. And in math, if you do something to one side, you have to do the exact same thing to the other side. Agreed? If you alter something in the numerator, you've got to do it in the denominator. Add something, you have to subtract something. It's just algebra. So when you take logarithms, you take logarithms on both sides. You can't simply put ln on one side, not put ln on the other. Okay, what is the advantage? Since ln and p are inverses of each other, this is quite squiggly. Go away. ln will get rid of e. So if those two go away, what are you left with on the right hand side? That's an easy question. Are we able to see? What do we have on the left hand side? 0.21 times t. Right hand side, I have ln of 2.66. Pick up your calculator. You press second ln to get the exponential. Simply press ln, type in 2.66. Tell me what you get. ln of 2.66.
0.97.
0.97. Two more decimals.
83.
83. Okay. We want to solve for t. Yes. Divide by 0.21 on both sides. Four decimals.
Oh,
4.86.
6586.
Okay. It's still sort of an approximation, but if I asked you, well, is this accurate, or whatever we did earlier is accurate, what would your answer be? This one is accurate. By all means, I can get more decimal places. I can get accuracy all the way up to probably 32 decimal places. No guesswork here. Agreed? Okay. What should you do here? In the problem that we did last time, same setup. Take natural log on both sides. So instead of graph, trace, answer, I simply do ln. I can't do it just on one side. I've got to do it on both sides. What happens to ln and e? Squiggly, they go away. One is the inverse of other. They get rid of each other. That is what I have. What is ln of 1.22? 0.2198. So divide by 5 on both sides. What do we get? 0.039. One more decimal. I'm just greedy for decimals. You may say why? More accurate. So the answer that I get is 0.0397. Last time it ended up being 4%. I guess that's the best we could do. Correct? More accurate. So given the choice between doing guesswork and recognizing that natural logarithm is the inverse of exponential, which approach should you take? Guesswork or this? No. This. Okay. Wednesday I will be wrapping up natural logarithms, so comfort